All right, today we're going to look at Unit 9, Section 2. We're going to focus on cylinders, doing the surface area, and then we are going to look at cylinders and prisms, looking at the volume. So first we are going to define a cylinder, calculate its surface area, define the volume, and then use formulas to calculate volume of a couple examples. All right. A cylinder is formed by two parallel and congruent circular bases and a lateral curved surface. So a good example of a cylinder would be a soup can. All right, so if we deconstructed that cylinder, deconstructed that soup can, so one thing you could do, for an example, you could cut off that label of the soup can and unroll it and flatten it, you would see that it has a rectangular shape right here. All right, we call that the lateral area, and it would have the top and the bottom as circular bases. So for our base area, to find our overall surface area, we take our base area, and a circle still has a radius. We're going to look at the area of a circle, but there are two circles, so it's 2 times a circle area is pi r squared, so it's 2 times pi r squared. All right, and then we have our lateral area. Because it's that label that got cut off and unwrapped, this side right here is the circumference of the circle that was the base. All right, so the length of that soup can is the circumference of the circle of the top of it. All right, and then we have the height h from here to here, from top to bottom. That's going to be the other side. So the area of this is 2 pi r times h. Okay, so overall, if we write it as this, we have the area of the faces, or of the bases, plus the lateral area, L, or you could say 2b times L, where b is the area of the base. But as an actual formula that makes it super easy to calculate, it's 2 pi r squared plus 2 pi r h. So you have to know two things. You have to know the radius of the circle of the base of the cylinder, and you have to know the height of the cylinder, and then you can find its surface area. All right, couple quick examples. Remember, radius is half the diameter, so if the diameter is 12, the radius is 6. All right, meters, and we are going to put it into our formula. So surface area is 2 pi r squared plus 2 pi r times h. Plug in what we know. 2 pi 6 squared plus 2 pi 6 times 9. All right, and start calculating it. 6 squared, 36 times 2, 72 pi. And 2 times 6 is 12, times 9 is 108, so 108 pi. Add those two together, we get 180 pi. Don't forget to bring your units back. So we had meters and its area, so this is meters squared. What your answer should have is number out front, then pi, then the units at the end. All right, if you really want to, you can multiply through by pi. It does make it look a little messier because you have a lot more decimals, but you could leave this as an answer, 180 pi meters squared, or you could multiply it and multiply through pi, and you would get about 565.49 meters squared. Either way is acceptable. I prefer this because it makes it the 180 pi, because it makes it look a little neater. All right. Example 2, radius is 3 centimeters, height is 19. Plug it into our formula. 2 pi, r is 3, so 3 squared, plus 2 pi times 3 times 19. Do some magical calculations. 18 pi plus 114 pi. Add them together, we get 132 pi. Don't forget our units at the end. Since it was centimeters, area centimeters squared. You could multiply through by pi and get a decimal, but I won't. I'm just going to leave it like that. All right, next. Volume is the amount of non-overlapping unit cubes it takes to completely fill a solid object. All right, where this is our unit cubed, 1 unit by 1 unit by 1 unit, which has a volume equals 1 unit cubed. All right. So thinking of that, as we look at prisms and cylinders, you could think about the volume as filling up shapes with little tiny cubes. We are going to go over a couple quick formulas for it. The volume of a prism, any prism, is the area of the base times the height. All right, so when you've probably done volume with a rectangular prism before, or a cube, where it was length times width times height. But if you think about it, that the base of that was the length times the width. So that's the area of the base times the height, which we would add at the end. So we can do the same idea here with a triangular prism. It would be the area formula for a triangle. Remember that if it's a triangle, it's 1/2, not pi, 1/2 base times height. If it is a rectangle or square, it's base times height. And if it is a trapezoid, it's B1 plus B2 over 2 times H. All right, this will get a little confusing if we have H's here in all of our area formulas and H's in our volume of our prism. Those are not the same H. So we're going to call this HP for height of the prism. All right, that's different than the height of a triangle or the height of a trapezoid. All right, volume of a cylinder is going to be pi times r squared h. And we'll just do a HC for h of the cylinder. So essentially that still is the area of the base. The base is a circle, so the area of that one's pi r squared, and then multiplied by the height. All right, so as examples, we're going to find the volume of a couple shapes here. This is a rectangular prism, so we find the area of the base, and that's going to be 4 times 5, which is 20. So the volume equals area of the base times the height of the prism. The height of the prism is 12. So 20 times 12 equals 240. And don't forget units, it's centimeters, so our units at the end are centimeters cubed. All right, all volume should be in cubic units, so just keep that in mind. All right, part B, we are looking at a prism or a cylinder. The radius is 6 millimeters. So the volume, we have a direct formula for that. Pi r squared times h. So it's pi times 6 squared times 23. And 36 times 23 is 828. So this is 828 pi, and then our units are millimeters cubed. And the last one, we have a triangle. So our base is this triangle, which is, find the area of that triangle. The area of the triangle is 1/2 times the base, which would be 5, times the height, which would be 12, which gives us 5 times 12 is 60, times 1/2 is 30 centimeters squared. All right, and then our volume is going to be 30 centimeters squared times the height, which is the height of the prism, HP, which is 10. So 30 times 10 is 300 centimeters cubed is our volume of that triangular prism. All right, so you have a couple practice problems that you can work on, and then I will see you next week.